Cool. Hello, everybody. We are back for round 2 of the Basic Electronics Workbook 1, brought to us by RadioShack, not sponsored. I don't think they're sponsoring anybody nowadays. You got myself, Shigi, also back with Crow.
Hey, how's it going?
And we're going to pick up where we left off. So let's open up to where we were. Memory suits us. Last time we built our first circuit.
That was fun.
Yeah, super fun. We followed all of the stuff and actually did some troubleshooting, which is kind of dope. The one thing I do realize is, kind of cheated and looked ahead here, and it looks like we weren't supposed to take it apart yet. So...
Practice makes perfect.
Yeah, practice makes perfect. So, now we're going to rebuild it. So let's go ahead and rebuild our circuit again. All right. First and foremost, turn the switch off. There we go. Cool. Now we're going to insert the 555 IC across slot 3. It's going to be pin 1 at F15, Foxtrot 15.
Okay. The proper tools this time.
And then we want pin 1.
Pin 1 is the one with the dot?
Is it? Okay, great.
I'm not sure.
I believe so. Yeah. Yep. Yes, it is.
The dot? Okay, top left.
All right.
All right.
Nice. Okay, I wonder if that dot's on all of the chips.
Yes, it is.
We haven't even... Is it?
Yes,
That must
it
be...
is.
That. Maybe that's how you orient them, so you know which way. That's sick.
Makes a lot of
Okay.
sense.
Did we miss that the first time,
So
or
what
we just
was
know? Oh, Foxtrot 15, pin 1.
Foxtrot 15.
Across slot 3. So on slot 3, looking for 15. Nailed it.
Alrighty.
All right. We're going to take a white wire, or any wire at this case, and we're going to go from I14 to F17.
Okay, let's get our wires out. I14 to F17.
You got it. What's your alphanumeric for I? Indigo?
Indigo.
What do you use?
India.
India. Oh, that makes more sense.
So India 14.
India 14, Foxtrot 17.
People are probably screaming at me right now.
All right.
Alrighty.
We have another wire. We're going Golf 14 to Hotel 15.
Okay, another white wire. Golf 15.
Golf 14
Golf 14
to Hotel 17.
to Hotel 17. Okay.
All right. A third white wire.
Third white.
And we are going to go from F20, so Foxtrot 20, to Volt V4, so the 6 volt.
F20 to V4 6 volts.
You got it.
Does it say row?
It doesn't. I don't think it matters. I think all 5 of them are basically available.
Okay.
Yep.
Pop it
All
right
right.
that front row, that top row right there.
Sweet. We're going to grab a red wire.
Red wire.
This one's going to go from F13, so Foxtrot 13, to the ground. You know what I noticed? It doesn't specify ground. I wonder if all of the bottom are ground. I think we went through this last time. I think they all work.
When they oriented us.
Yep. Foxtrot 13.
Fox 13 down to the ground, and it doesn't even dictate what kind of ground, right?
Does not. Just says ground. Red wire. I bet you anything these wires are very
grounded.
important. All right. We are going to insert R1 across G19 and 6 volt. So, all right, R1 is our first resistor, and that is the 4.7.
4.7.
4.7, and that is going from Golf 19 to the 6 volt.
Just so you guys can see, this is our resistor there.
I don't know if it's
Okay,
even...
those bandings, the banding marking on them does indicate their use. This is a 4.7.
Yep, indicates the resistance. And that is a yellow, violet, red is the order. So yellow, violet, red.
And my destination for this again?
Destination is Gulf 19 to our V4, so the 6 volt, so power.
Okay. So Gulf 19. Go ahead and slip this guy in there. And it goes to our power.
You got it.
Okay.
All right, we got our second resistor, so R2.
And that is a
10K.
10K.
Brown, black, orange color scheme.
10K brown, black, and orange. It's very important if you don't have a chart on hand to be able to know what those mean.
I think I was looking, and I think that there's like multiple charts too, which I hope I'm wrong, but it looked like there's multiple charts.
Trying to get this thing out of here.
Because if there is multiple charts, that means like there could be potentially crossed over colors. I hope that's wrong. I guess we'll figure that out when we cross it.
Okay, so you guys can see that.
No, you can't really see it. Can't make it out too well.
All right.
Yeah.
That's okay.
It's all good. All right, so we're going from Gulf 20
Gulf 20
to Hotel 20.
to Hotel 20. Got it. Come on, get in there. Here we are. I hope that's where we are. We're not. We're touching the other one. So let me back out real quick.
Oh yeah, that's the problem we were running into before, right? Where it was touching.
That may have been one of the issues that we had. I know we had. You also had some creative use for the resistor as well.
Oh, that's right.
Which was pretty cool.
All right.
Okay.
And that was our third one, right?
That is our
Second one.
resistor.
Second. All right. So our final resistor, R3 for this circuit, anyways. It is going to be the 1K,
1K.
and that is brown, black, red. Ooh. So the 10K is brown, black, orange, and then the 1K is brown, black, red.
Oof.
That's not. They're not really like inclusive to the colorblind.
I guess not. No. So hey, you're in trouble, guy. I'm sorry. This is choose a different line of work.
That's kind of messed up, man. I guess you could always hook up like a voltmeter to it, right? And see how much resistance you're getting to it. That'd probably be a good indicator.
For sure.
At some point, we gotta bring that and figure out how the hell that works.
We definitely do.
Oh, I'm sorry. Let me give you the numbers. So it's delta 15, and that one's also going to V4, the 6 volt.
So delta 15.
So that means we're pulling in power from three different pieces of the circuit. Oh yeah, it makes sense. 6 volt, 6 volt, 6 volt. It all comes down, and each piece goes into that that 555.
Yep, but they get intercepted by the resistors, which make them slow down or trickle into this capacitor.
Which is probably why
Which
it
will.
works. I mean, we'll get to it in the next page, I imagine. All right, so we're going to insert the LED 1 across D13, the anode, and H13, the cathode.
Okay, so do you...
All right, so I think we just went into the LED last time. So
Yeah.
take D13.
Okay, so delta 13.
Delta 13, and then go into, I believe it was
down
the
here?
bottom one, maybe? Well, if not, we could swap them.
We will give that a try.
And then the next one is Hotel 13.
Hotel 13.
And bring that one up to the other spring on the other side of the LED.
Okay, 1 second.
All right, and now we're going to go to the capacitor. Capacitor's a 10U.
It is a 10U, and just so you guys don't forget, the short wire is the ground.
We want G11 positive, so Gulf 11 is the positive side.
Okay. So Gulf 11 positive, where am I going to? F11?
F11 negative.
So Gulf, oh, that's hotel. There we go, Gulf 11.
There was a thing in here that told
There
you
was some
which one it
information. That's what I tried to relay, but now I'm second guessing myself.
No, I think you're right. I just want to find where it was.
There it is.
Shorter wire is ground. Okay, cool.
So
Found it. It's that piece right here where somebody looks like somebody handwrote it in, but I think that's actually printed on where somebody probably proofreading wrote it in, and then they just published this proofreading.
I believe they said in the beginning there were many experts that read through that book.
That's pretty cool. All right. So now we got to test the circuit. So fingers crossed.
All right.
Turn it on. Nope. Here we go again. All right. Turn it off. Swap those wires on the springs. Let's see if they work.
Oh, come on. I can't do this. There we go. And there we go.
Got it.
All right.
Turn it on.
On.
Uh-oh.
Excellent.
Okay. Well, I got an idea.
Troubleshoot time.
Troubleshooting time again. It's all good. We did good last time. Let me take some of the other wires. We have any longer ones? We don't. Need a longer guy.
That yellow one's pretty long. We could probably trade that out for one of these. That yellow one over there. This white one right here. There's a yellow one in there that's pretty decently long. Yeah. Oh.
Nope,
I guess it's
pretty
not.
short.
Red maybe?
No, they're all the same size. Every time, dude. Oh, here we go. Wait. Nope.
Oh, yeah. There you go. That'll not help us.
They are male to female. I think we have a whole thing of male to male out there. Hold on. We have a whole thing of male to male. We're going out anyways.
Alrighty. Anyone monitoring chat? What do we got?
I don't think we have any chat yet. I think we're too early. Okay, so we got these cool. This is male to female. I grabbed the wrong ones. I think we got it. After a nice trip to the Micro Center, got ourselves some nice long male to male. Bam.
Does look like we have a couple messages.
Look at these guys. Oh, we do?
Oh, yeah. Look at those.
All right, let's just take 2 of these, peel those right off.
Satisfying.
3 of those. It is actually really satisfying. These will kind of do us. All right. So I was thinking we do some testing.
Okay.
So, independent of our little circuit here, I'm going to plug that in to the negative. I'm going to plug that into the positive. Let's turn this on, and let's just see if we can get some LEDs to go. So this is the positive to the low. Yeah, there we go. Okay. So the positive is going low. Let me swap them, make sure they don't work. They don't. Okay.
So this is definitely user error. Now we just got to figure out where we...
Let's see. Could be the ground, right? Let's take that off. Let's try moving the ground down. Turn it back on.
Now while we're doing this...
I'm going to try running more current through it to make sure that it's not that. No. Okay. Let's put that back. Is that guy touching? Some of our resistors might be touching.
They may.
I'm going to bend this guy just a little bit so that that's not touching. Seat that one in there. Seat that guy in there. All right. Those aren't touching anymore. Let's see. Nope. We don't have anything. All right. You want to read them off and I'll double check?
Okie doke. So, push power to off.
It is off.
Okay. So our first is the 55 IC across slot 3. That's the pin 1 at F15.
Pin 1, F15. Looks, oh, I had to push it down. It wasn't in all the way. Let's try it again. Nope. All right, let's go next.
Next is connecting the white wire from I14 to F17. That's India 14 to Foxtrot 17.
All right, so
These ones are kind of tight. So
India. Yep, I got you.
Be where a mistake might be.
India 14 to
Fox 17.
Fox 17. Good.
Okay. We have G14, Golf 14 to Hotel 17.
Golf 14. That's going to be the second white one. This came out too. All right. This second one to Hotel
17.
17.
It'll make sort of a figure 8.
Yeah, that one's kind of loose. Let's pop that guy.
So these were a little tough to get in there. So.
Yeah, it's kind of weird. All right, go ahead. We're good.
Okay. Next one is Fox 20 to Victor 4.
All right, Fox.
Maybe that's important.
20. Fox 20. Yep. To V4, 6 volt.
Yep, it doesn't say where, so I guess that's not that.
Yep, we're good.
Fox 13 to ground, that's the red wire. Fox 1-3.
Fox. Oh, we're off one.
Are we?
Yeah, you got it in golf.
Okay.
Yeah. All
excellent.
Right. So it was Fox what?
Fox, let's see, Fox 13.
Fox 13. Well, that's an important one because then we didn't have a ground.
For sure.
So
we weren't discharging your capacitor.
Nope. All right. I thought for sure that would be it.
Well, let's see. Where does it say to ground? Red wire. Okay. Insert the first resistor. That's our... which one was the first one? The 4.7. And that goes to Golf 19 and to the 4 volt 4. The 4th volt section.
Golf 19 to power. Yep, we're good.
Okay. Insert R2 across Golf 20 and H20.
So resistor 2. You say Golf 20?
Yep, to H Hotel 20.
Golf 20 to Hotel 20. We are still good.
Okay. Next one is R3 across Delta 15 and Victor 4. That's our volt.
Delta 15, 2 volt. We're good.
Okay. So we have LED 1 across D13 and H13.
Right,
so LED 1 goes to Delta 13 and Hotel 13.
There we go.
Were we backwards again?
We were backwards again, but it's because we swapped them
when we had the
when
ground
we were trying to figure it out. So I think that ground was our issue. I think we just had it one row off.
And as you see, the best way to troubleshoot is step by step.
Step by step.
And the first step is always switch it off.
Switch it off. All right, cool. All right. Well, let's. I think the next page walks us through what we did.
Excellent. So
test is. You want to do it?
This is our second time through. All right, sounds good. And this simple circuit is easy to modify. To slow the flash rate to about once every 2 seconds, you can insert a 100 UF capacitor across C1 at G12 and Fox 12 to trigger a shrill tone from the buzzer each time the LED switches on Use blue wires to connect spring 67 to Hotel 11 and spring 66 to Victor 4. The 555 timer is amazingly versatile. More applications for the 555 are given later in this manual. Be sure to compare your circuit with the pictorial view on page 16. You will find some tips that will help you build this and other circuits. Just so you guys know, when we built that circuit, this is actually what it would look like in a sort of breakdown of the blueprint. If you guys recall from our lesson 2 weeks ago, we had a breakdown of the symbols. So what you see on our other screen there is also represented by this fancy blueprint, and even further by this layout. Alright, so on to the next part. Checking out the circuit. So if you added thank you.
You're welcome.
If you added the 100 UF capacitor, your LED flasher circuit should now be flashing several times each second.
Oh, do we want to swap it?
Maybe it's not working. You know, maybe we can try this.
Maybe it's not working. They just said it's either flashing or it's broken. I feel like we're starting to get to a theme here.
We've discovered that, actually. It's either going to work or it won't.
So it said it's going to flash faster?
It says if you attach the 100 UF capacitor, it'll trigger a flash rate at about once every 2 seconds. It doesn't say to remove any capacitors. So
I think we have to swap it.
Well, it says the 100 UF at G12 and F12. Let's see, the capacitor is at G11 and F11. So what this does is this adds more room before it discharges.
Yeah, that makes a lot of sense. Okay, 100U?
100U.
All right, let me swap this. Where are we at? We are in...
We're going to Golf 12 and Fox 12.
Golf 12 and Fox 12. I got you.
Long wire in Golf 12.
Got you. Okay, let's give that a go.
All right.
So take you out. Well,
First no, that one stays in there.
No way.
Yep. Because that one's at Golf 11 and Fox 11. So we're going to the next one. We're adding more storage, essentially.
So that's going super fast.
And then we add some more storage, and then it'll slow down a bit, at least.
Golf 12 and Fox 12.
That's what it says here.
All right. Let's give it a go. I trust the book.
All hail the book.
All hail the book. Oh, man, this is... I'm going to bend that out of the way a little bit. I'm starting to see where you were having problems.
Yes. Yeah, that was the tweezers there.
All right. I think I've got these in. All right, so now it's supposed to go slower?
It oughta.
I don't think it did.
I don't think it did either.
Out of curiosity, I'm going to take this guy out.
Take that one out?
Yeah. Nope.
Okay.
So either this one wasn't in right, or Golf 12 and...
We do have to keep in mind that we may need to try more than one capacitor as well.
That is true. These are old.
Yep. Specifically, capacitors will like
Let's
to
make sure I fixed it again.
blow
Okay.
on you.
All right. We'll put it back into it a little bit. I should probably just stop messing around and get to the understanding of what we did. All right. Cool. So where are we at?
All right. So, if you had added the 100 UF capacitor, your LED flasher circuit should now be flashing several times each second. Or maybe it's not working. Either way, compare your circuit with the one below to see what you did right or what you did wrong. So look, it actually shows us exactly where that circuit would have went.
Oh.
Where that capacitor would have went. And as we can see, he gives us a little bit of troubleshooting information, such as when a circuit fails to work properly, push the power switch to off right away. And again,
We did.
troubleshooting 101.
Turn it off.
It's okay for this bare LED wire to touch the adjacent insulated connection wire, so we don't have to worry too much about the capacitors. The 555 IC pin 1, usually marked as shown, must be inserted at hole F15. ICs must be installed over a slot. The index marks should always point up. So that's actually a really good troubleshooting tool. If you are not installing your IC across a slot, then you're wrong.
Yeah, because all of this is shared. These are all connected, right?
Yes.
So all 5 of these are connected. That's why you go over the slot, so that we're actually creating a bridge.
Yes, we are.
That makes sense.
Okay.
Cool.
Well, that's good to keep in mind for sure. The circuit diagram shows 3 leads going to the 6 volts. Here they are. Be sure to use the voltage given in the circuit. These letters are printed on the left and right edges of the breadboard. They are moved closer to the IC in this drawing so you can more easily check the connection points. The arrow at the left points to N24. For best results, keep the area around your circuits free of unused parts. Since these 2 white wires are installed close together, be sure they go to the correct connection points. Their insulated portions can touch. Note the flat spot on the rim of the LED base. This marks the cathode lead. Oh.
Yeah, we don't.
Okay.
So we don't have one. Like, if we don't have the LED here.
Oh, this is the LED, not the capacitor.
Yeah.
Okay,
So we're actually
okay.
we're using these on
We
on
are.
the tester
Yes, we
board
are.
LED. But normally there's like a flat spot on a little LED. Do we have? How do we not have any LEDs in here?
I think we have some clear ones. I thought I saw a clear one.
There's a bunch of clear ones out there yet again.
Yet again.
It's in the box.
Look at this one day.
It's in the box. Big box with all of our soldering testing boards or badges. We have all these parts, and you never find the part we need. I swear, this is why Micro Center's still in business, is because you have things like this lingering around. We can never find any of our stuff. You get one? Okay, you got one. All right, cool. So inside, haha, it's a little tester kit. Here we go. So it's this. So when you have the LED, you get to see how it's rounded all the way around, but there's a flat spot right on the front, which tells you, where is it? There it is, right here. So on the side, see that flat? That's the indicator of what side you're on. Normally, though, there's one that's longer and one that's shorter. It's the same thing with the capacitors. But that's another way, is they kind of flatten out the brim of the LEDs to tell you which one is which.
Yep, and they are polarized and polarized.
Yeah.
They
We
are
stole from this
polarized and must be installed correctly, otherwise they will not work for you.
Right. That's kind of what happened when we did this. So when this flashes, but by swapping from side to side, I'll put that in. When we just swap those two, nothing happens. So they have to be. Oh, is that where the, what is it? Anode.
The anode and the cathode. The
Cathode.
anode being
There we
the
go. Positive?
let's see, LED 1 across T13 anode, H13 cathode. The flat part marks the cathode.
Oh, okay.
Cathode is the negative,
There you
anode
go.
is the positive.
So it's the anode. Yeah.
Excellent.
Cool. That makes sense. I'm gonna need to hear that like 20 more times
Yeah.
before that actually sticks.
You're going to have to use that word. Absolutely. Okay, so the loose connection wire is red. It goes to any of the 30 ground points below.
Okay.
The capacitor, C1, is installed close to the LED. Be sure their bare leads do not touch one another. So
We didn't have, it would have been there, but we didn't do it. Yeah.
So just like resistors, capacitors can't touch. Okay?
Yeah.
Cannot. Sorry. Do
Yeah,
not let
because
them
it'll
touch.
create like a short.
They will definitely short.
Yeah. Okay.
And it is not okay for the bare wires of parts to touch any other bare wire. That seems like the number one most important thing.
Yeah. Don't
to,
let the
keep in mind.
don't catch anything on fire.
Pretty much, yeah.
Yeah, I
Don't make
appreciate
arcs. To protect your learning lab and for best results, always switch the power switch to off before building or modifying a circuit. After you build a circuit, carefully check for errors before switching the power back on.
Well, we did.
Excellent.
Yeah, we're on top of not setting things on fire so far, so it's working out pretty great.
Yep. So,
Where are we at?
we can build the circuits in the manual in order or randomly. So, you can quickly learn how the projects are presented. Begin with the 555 LED flasher on page 15. The explanations below show how this and most other project pages in your 2 learning lab manuals are organized. While detailed assembly instructions are provided with each project, eventually you will be able to build the circuit straight from the circuit diagrams.
Oh, so we'd be able to build this. So this is basically that.
Yep.
That's cool.
And you know what? You can kind of see it too.
Yeah, no, I do. It's nuts. Like, this is where our resistors came in. This is our white power. It's kind of crazy because we're going to have to understand the breadboard so well that we could see this and we understand what's going where.
Well, they're letting us know that they will stop giving us instructions and make us have to follow the diagram.
I'm already having a panic attack.
That's got to be fun.
All right.
All right. So, as you guys see, there is a generalized layout of the pages. I'm sure this is more intuitive than they expected, and so I won't go over this.
They made you read anyways.
Troubleshooting. Everyone's favorite thing to do. Your circuits should work the first time you push the power switch on. If you follow the step-by-step instructions, use the correct parts, and don't become rushed. But sometimes the circuit will not work properly. While this can be frustrating, it's a routine part of experimenting with electronic circuits. Here's how to troubleshoot a problem circuit. Push the power switch to the off position. Step 1.
Off.
Be sure batteries are installed in the console. Check to make sure they are installed in the correct direction and that they are fresh.
So we did that when we actually just plugged it in.
We'll have to get some rechargeable batteries so that we can
Oh, that's not a
just
bad
keep
idea.
some on hand.
Yeah, that's not a bad idea.
Be sure that exposed wire leads do not touch one another. The wire connection leads can work loose. Be sure all the leads are fully inserted into the breadboard. That was one of our troubleshooting actions. Check to make sure you didn't leave out a part or wire. That's what we did when we went through the steps.
Yep, we're good.
Make sure you installed the correct parts. Double check part numbers and resistor color codes. If the numbers on diodes, transistors, and ICs are hard to read, hold the part under a bright light.
Just still messed up for the colorblind.
They even tell us red can look
so
like
messed
orange.
Up.
Like,
yeah,
come on, guy.
red can look like this thing. We didn't change it. We realize this is an active problem. We realize we're discriminating against colorblind, but haven't figured out a better strategy yet.
This is going to be brown to some people.
Brown, yeah.
Yeah, there you go.
It's like black, brown, and red, black, brown, and orange, right?
Yeah,
Are the two?
Boy.
That's messed up. All right.
Okay, so diodes, transistors, and integrated circuits must be installed with the leads or pins in a specific direction. Be sure none of these parts are installed backwards.
Wait, which one? Diodes and what?
Diodes, transistors, and integrated circuits.
Oh, okay. So the integrated circuit works out because we got the little dot.
Little dot.
So that's good. The diodes we know because we have the flat spot, also the long end, and then the capacitors we know because, again, the long end. But I don't see anything that indicates it outside of that.
No, we'll have to figure something out for that.
I mean, they all look kind of long and short, thankfully. But if somebody was ever to snip these, like if you were to put them into a circuit and solder them in, how would you know?
Is there a positive negative?
So let's see. The short side has this blue stripe, this light blue stripe on it. Does the other one also have that light blue stripe on the short side's the ground, so the negative, right?
I'm not seeing that.
So do you see the zero? You see the blue, light blue?
That looks like an arrow.
It kind of does. Now are they all like that?
Let's find out.
Because maybe that's the indicator, right?
Okay. And that one's on the short side.
It's on the short side too. Okay, so cool. On the capacitors, it looks like the light blue indicates the ground. Awesome. Okay, I think that's a good fall. Oh, there's black ones. Here's a black one. Let's take a look at that.
Does that also have arrows as
It does.
they look indicating?
And it does look like it indicates the short. Okay, cool.
Excellent.
So that's how we know on capacitors.
All right.
And the indicated is ground. So
Learn while we're learning.
Learning while we're learning.
All right. Digital logic ICs are CMOS devices. All their unused... do you know what that means?
No. Circuit managed something? Operating system? Circuit managed operating system? I'm making that shit up. I'm making it completely up. I have no idea.
I think we had a...
I don't think it's really an operating system, is it?
I don't believe so. It told us what the IC was when we first started.
It did.
Here we go.
Did it tell us what CMOS is?
LED, the breadboard, transformers.
Let's see. CMOS. Complementary mental... Oh, man. We are way off. It is a complementary metal oxide semiconductor. That's what CMOS stands for.
Excellent. Complementary
metal oxide
semiconductor.
Yeah, I'm never going to remember that. All right. Actually, I might. That's one of those weird ones that stick with you.
Yeah, it might be one of those that you just kind of sort of keep around.
I like my idea better. Circuit managed operation.
Yeah, for sure. Frequently used mechanical parts, like the console switches and potentiometers, tend to fail before components without moving parts. If a circuit doesn't respond when you press the switch or turn a knob, try bypassing the switch or pot. Bypass the switch by squeezing its contact springs together. If a potentiometer doesn't work, try using another pot, or substitute 1 or 2 resistors for the pot. If you took shortcuts or made changes to a circuit, try rebuilding the circuit exactly as shown in the circuit diagram. Make changes after the circuit is working. If the circuit still fails to work, check the connections of each pin or lead against the circuit diagram. If the circuit uses an IC, check the connections in each pin. Begin at pin 1 and work around the chip pin by pin. You will quickly find missing or incorrectly installed wires and parts. Often you can fix a circuit faster by rebuilding it than by trying to find a wiring error.
They said just rebuild it instead of just doing what we did?
We essentially rebuilt it. We went step by step.
That's true.
Really?
That's true, yeah. We just kind of traced it. That's fair.
So, as a last resort, remove all the wires and parts. Make sure all the parts are the correct ones and start over. If the circuit still fails, a part may be bad. Try using a suspect transistor or IC in a different circuit. If that circuit fails to work, the transistor or IC may be bad.
IC is integrated controller, right?
That is our... Yeah, I'm pretty sure that's what it said.
Integrated circuit?
Integrated circuit.
Integrated circuit. Okay. All right, cool.
All right. So, now we are about to build a black box test circuit.
Sweet.
A black box test circuit is one that's there when you need it. You can use it even if you don't know how it works. This black box test circuit produces a tone with a frequency controlled by a resistor and a capacitor. It will help you understand how resistors and capacitors work on their own and together. So we are going to install R1, R3, and C1 when you use the circuit for various tests. Oh, so this is going to be a circuit that we will keep around or have to rebuild.
Oh, man. Do we want
Just so you guys know, I'm on this page. I'm sorry.
Do we want to get a little breadboard and try to build this thing outside of... We don't really have a 6-volt or anything. We could plug it into that for now.
We could connect the breadboard to the 6-volt just for power, and then keep the circuit on the breadboard, and then we could remove it, and that way we can have it like on hand.
Let's build it on here first, and then we'll transition it over to a breadboard, and then we'll keep it.
Practice makes perfect.
Oh, I even have blanks. We could just solder it in permanently.
Nice.
Yeah, so we'll do that.
Oh,
okay.
Yeah, and then we'll have our own first machine.
We'll have our own first board. All right,
first
cool.
machine.
All right, I'm going to disconnect our stuff, right? We're moving on to a new one.
Disconnecting our stuff.
All right, pop those guys out. We're going to pop these guys out. Pop these guys out. Okay, what resistors do we need for this project? Let's see. We need a 10K. 10K is, it was brown, black, and then orange, right?
It is brown, black, and orange, which sometimes looks like red.
think this is red. This is why nobody likes this.
Which one was that one? Do you remember where it came from? Well, what are the other two you got linked up there?
So we have the brown, black, and orange.
We have
Or red, rather. We have brown, black, and... Oh, that also looks red. This is terrible.
Okay, so Delta 15.
I don't know which one I just pulled it out of.
Okie doke.
Let's see. This looks like brown. This is so terrible. How can you tell? That looks like brown, black, and black. Brown, black, brown? Oh, you know what? I can compare them to the existing ones that we have. So we need what? A 10K?
We need... Yes, a 10K,
All
a
right.
1K, and a 100.
Let's take a look. That is not a 10K. Let's take a look at this guy. For anybody that's on that maybe can't see, I'm just trying to compare the color that's not this one. And maybe this guy. That looks right. So this is our 10K.
Okay.
I'm going to just set it off to the side on top of that. Let's take, what's the other one we need? 1K?
1K.
All right.
That's our brown, black, and red.
Brown, black, and red. This is so crazy that this is how they do it. But I get it though, because it's so small. Like they kind of have to do this, right? It's the only thing that makes sense. Don't believe that's it. Let's take a look at our other one. I think Krill fell over out there if you heard a loud bang. I don't know what's going on. Oh, there's our 1K. Okay, cool. We got our 1K. And we needed, let's see, 10K, 1K, and a 100. Brown, black, brown. I think that's a new one that we need. So let's see if we can find some handy dandy 100 in here. Now is that 100 or 100K? What are we looking at? Okay, no, just simply a 100. Okay. So 15K. Take a look. Let's see what we got. 18. 5.6, 120K. That's a crazy resistor. That thing is bigger. That's so large. That's cool. Oh, they actually they change in size. That's dope. 22R, 390, 6.8, 33, 1 million. That's nuts. That's thick. 27, 100, 33, 390, 27, 560, 560, 10R. I wonder what the difference of that is. What is R? Oh, wait, I have a list here. Let me make sure that we actually have 100. It's 100K. Maybe it's supposed to be 100R. Is that what 100R means? 100 resistor? Let's look at the color scheme. So it's 100. Alright.
How's it going?
So, I'm trying to figure this out. I'm assuming they say 100 in the book, right?
Okay.
But each one of them is followed by a number, like a letter. So there's 100R, which I did find. which I'm wondering if there's like 10R, but I think R might be bigger than the K. Do we have any resistors in
That one says it's brown, black, brown.
All right, yeah, that's what I'm thinking. So I'm going to look for the 100R that I found. I passed it.
Okay.
It's so much thicker, which is crazy. Oh, I'm just dropping resistors. Can't stop, won't stop. Resisting. That's such a dad joke.
Amazing.
That's so bad. All right, 100K. 1, 10, 115, 120, 150R, 82R, 180R, 33R, 15K, 82K. There's no order to this whatsoever. This is pure chaos. We should probably sort this, dude.
That's probably a good idea.
15R. So, like, look at the size. Something's telling me that, like, the size of these things are insane, right?
Okay, I see them, definitely.
Yeah, so I'm assuming if they're larger, they probably have, like, they withstand a larger amount of current, so they're probably, like, resisting more. So I'm wondering if we're going the right direction, or if they just want, like, a 10K resistor. Do we have any in there?
That's what I'm checking. Sorry.
Well, there goes beer on... Oh, no, we're good.
Alright. Do we have...
Yeah, there's probably paper towels out there.
we
We should probably get to that before it hits any of the electrical stuff.
Absolutely.
This is how serious we take our learning over here. Yeah, should probably not start a electrical fire while we're working on this. Alright. Oh, there we go. Let's put all those resistors back in there. I should just look at these like Pokemon cards. 10R. There's our 10R.
We're looking for 100.
Oh, crap. Okay. I'm going to go back. 22, 270, 390, 39. 100R. Got it.
Alright.
All right. I'm assuming that's what we're going with, so I'm grabbing it. I sorted the other two, so we're in good shape. Okay. The last one was a the one we used in the last one was a 4.7K, right?
That is correct, yes.
Okay, because I got this guy right here.
That was our brown, black, and orange.
I don't want to waste it. I'm going to compare. It looks good to me. We're going to drop that guy back into the bag so we actually have these.
Smart.
Something tells me we're not done with them yet.
Brains are tend to be required for stuff like this anyway, so good
Yeah.
practice.
It's good practice. Okay, cool. And then what are we looking for around here? We got our resistors. And it looks like we need a small capacitor. A 0.1 UF.
0.1.
0.1 UF. I don't think we're going to have it in this, guys. So let me take a look. I think those capacitors are the little thin ones, right?
It's likely in the little. I do remember seeing one of them when I looked through that package there.
This is 0.47. This is 1 UF. Is it just single one? I think it's just a 1. Let's see. That's another 4.7. That guy looks too large. Maybe this little guy? 0.47. That's 100.
Tiny little guy. Yeah.
Yeah, it's gonna be a little guy, like itty bitty. 0.47. Yeah, so I think it's the flat circle guys. Like they're probably, I think I've seen them before. They're brown. They look more flat than rounded. Yeah, that's a big guy. We gotta start reading ahead to see how far we're gonna go, so we can have all this stuff out.
We did build one. We even had to troubleshoot it too.
Yeah.
So we didn't go nowhere.
Man, I really want to build this guy though.
Me too.
Oh, yeah, look it. See these?
Mm-hmm.
Are those NCs? Oh, shit. UF. The 10s. Man, I really wish. Oh, you know what? Let me go check some of the other kits to see if they actually have pieces in it. Because maybe they'll actually have the pieces that came with the initial one. It's a long shot. We got some more of these boards. Well, let's see if we can actually pull something off. All right. All right. Do you want to keep reading ahead and see if there's anything else we need?
Yeah. So it looks like for the circuit diagram, the numbered circles are springs on your console. The springs are borrowed from unused parts. Be sure that the DP-DT switch is pushed down. For test purposes, the circuit can be shown as a box with external connections like this. Leave this circuit on the breadboard while you build the switch, resistor, and capacitor circuits on the following pages. Switch the tone off by removing the red wire at V4 until needed. If you guys remember, we were looking at what DP-DT means, and DP-DT is a very hard thing to say. Just hangs right on the tongue there. And the DP-DT switch means double pull, double throw, and that means it's got 3 triggers.
Alright, I think I found some more. Ton of capacitors here, but let's see. What are we looking for?
We are looking for a 0.1 UF. It is a 104 capacitor. It's one of those one of these little orange guys.
One of the little orange guys?
Likely.
Okay. Whoa.
Yeah, let me take a peek at one of them.
Yeah, there we go. It's these little dudes. Oh man. There is no way I can read any of that stuff. We got a helping hand anywhere?
This is a 2-2.
You can see that?
On this one, at least. I get that big.
104?
Oh, 104 is us.
Is it?
Yes, it is. 104.
It says 104 on it?
Yes, it does. 104.
Oh, hell yeah. 104 right there.
Excellent. Too
Wow.
easy?
That's crazy. What a find.
Yeah.
Okay.
So
that's insane.
The book says we're going to build this circuit, and then we're going to leave it on the breadboard while we build the next 3.
Oh, okay, awesome. I'm glad did you find that when you were looking ahead?
Yes, I did.
Okay, cool. All right, so we're good. We have our 10K, our 1K. Potentially, nope, we don't need the 4.7. We can put that back in there. We need the 1R, 100R. Right? Resistor?
100, yes.
100. I'm hoping this is the right resistor. We don't need these capacitors, and I think we're in good shape. All right.
Man, it should be running out of time.
Oh no, what time is it?
5:45.
Oh no. Do we have enough time to build this guy or no?
It's a few steps. We might be able to, but it is a few steps.
All right, let's give it a quick shot, and if it doesn't work, we'll leave it and we'll troubleshoot it next time.
Troubleshooting, rebuilding, that's the whole course, the whole purpose of this.
The whole purpose of stumbling our asses through this.
Yeah.
All right, cool. Let's go. What do we got?
Okay, so the first one is to push the power off.
Power off. Confirmed.
Insert the 555 IC across slot 3, pin 1 at F15. So we're at the same pin area that
I left it right in there, so we're good.
Rocking. Okay? We're at white wire I14 to F17, India 14 to Fox 17.
India 14. Fox 17, you said?
Correct.
17. Clear.
Golf 14 to Hotel 17, white wire.
Golf 14 to Hotel 17. Clear.
Okay. Connect F11 to ground. Red wire. Probably to keep us oriented.
Understood. F11. Let me check it. F11 to ground.
Okay.
Clear.
Fox 20 to volt 4. Red wire.
Red wire. Got you. Grabbing a new red wire.
There's a couple in here too.
Oh, I got one.
Short guys.
What was it? Fox.
It is at Fox 20 to volt 4.
Fox 20. V4. Clear.
Insert R2 across G20 and Hotel 20.
Which one's R2?
1K, brown, black, and red.
Say Gulf 20.
We are going to Gulf 20 and Hotel 20. That is correct. So I believe when it says across G20 to H20, that means if there is any sort of short wire, long wire, probably go positive, negative.
It's a resistor, right? R?
It is, yes.
Yeah, okay. So we're Gulf to Hotel. We're good.
Gulf to Hotel. Connect spring 40 to ground.
One sec. Just want to make sure that it's not touching. Okay, we're good. What was it?
Spring 40. So that's this DP-DT switch here.
Oh. To where?
To ground with a white wire.
Spring 42 ground with a white wire. All right.
Alright, so now instead of
Ground.
blue wires, we'll need
Blue wires. Let me
4
peel some of
blue,
these.
2 red.
4 blue, 2 red. Okay. You're going to have a ton of wires here. So I'm going red. Orange is now going to be partial red because we ran out of reds. These are the wrong ones.
Oh, yes they are.
Awesome.
Excellent.
Get those out of the way. Oh, wait. Yeah. Do you want to use these or you like the other ones? The pins?
I think I like the pins.
I like the pins too.
A little bit
Alright.
better handle on them.
Let's go here. So we are doing reds.
2 reds, 4 blues.
1 red. We'll
You wanna
combine.
Get one of these and I'll.
Don't hold that. Oh, I don't know why I gave you that. All right, we're gonna go blues and greens are the same. Peel green. That's bluish green. That's why I'm kind of going with that. That'll give us our stop. That'll give us our 4.
Right there.
And
Awesome.
I don't want to mess with the reds, so I'm going to give us another red. So we'll peel that. Let me put these off to the side for now. We'll get us another red. We're good on red. All right, cool.
That's our male red.
Yeah, that's. Oh, it's a male.
Male red.
Oh man, so we have 3 reds.
Excellent.
All right. Did I miss a blue somewhere?
So usually
One,
we're
two-
either
no, we're good, we're good.
over prepared or under prepared.
Yeah, I know. We're good. All right. So read it off to me again.
Okay. Connect spring 40 to ground. That's what you already did.
Yep.
Green spring 41 to Gulf 11. Blue wire.
Blue wire. Spring 41 to Gulf. Say Gulf 11?
Gulf 11.
Must have been. Is that Foxtrot? It is Foxtrot. Okay, we're good.
Okie doke.
Clear.
Red wire. Spring 43 to I-11.
Spring 43 to Indigo 11. Clear.
Spring 44 to Gulf 17. Blue wire.
Spring 44 to Gulf.
17.
Heard. Gulf 17. Come on, buddy. I promise.
That's the twist. The
Fun part of it.
tweezers. As the tweezers there.
Yeah, that one was tight. All right, we're clear.
Okay, that was Golf 17.
Heard. Yep.
Okay, so Blue Wire, Spring 68 to Fox 18.
Spring 68. We're going to the speaker now.
Yes, we are. It's going to emit a sound with the flick of a switch.
To Fox
Fox 18.
18. That's third on Fox. Fox on 1. Clear.
Okie doke. Blue Wire, Spring 67 to Hotel 1111.
Last one was Spring 68.
Yep. So now it's Spring 67 to Hotel 11.
67. There's multiple things we're hooking up here. 7.
This is for testing stuff, I guess.
Yeah, no, that's cool.
Crazy.
Hotel 11. Man, we got a small gap here, but at least I know that we're good on the rest of them. Otherwise, it would be taken.
Yeah.
All right, we're good.
Okay. Red Wire, the last red. Spring 52 to I-20.
Spring 52 to I-20.
I-20.
We haven't completed any of this stuff. What are we building?
Well, I
Okay.
guess we are about to. We are going to assert R1. That is our
104.
10K.
Or 10K, sorry.
Brown, black, and orange.
Brown, black.
Pairing orange and blue was a bad choice.
Dude, that looks red. All right, whatever.
All right.
Where's our 1K? Where'd our 10K go?
It's in there. It's right there.
Oh, yeah.
Oof,
Oh, yeah,
don't wanna knock any of those
comparatively.
wires.
Comparatively, I think we're good, though. They're all solid-ish.
All right, so that one goes to Springs 43 and 44. What?
We're connecting a resistor to 43 and 44?
Yeah, but where's 43?
Right here. So this is our 43.
Okay.
That's our 44.
Okie dokie.
We're throwing resistors into the springs.
I guess we are.
This is crazy. Okay.
This is why crazy people do this.
All right, we're in.
Next is R3. That is our 100. Brown, black, and brown.
Brown, black, brown. This has got to be it. So it's 100 R's.
Okay.
All right, where's this going?
6, 7, and 6, 9. I didn't like
That's
that time.
bridging our speaker and our buzzer.
Oh, okie dokie.
All right.
Maybe it's supposed to be a limited amount of noise. That way, if anything interrupts it, it stops.
6, 7, and 6, 9.
6, 7, and 6, 9.
All right.
Insert C1, our capacitor,
Yes.
across springs 40 and 41.
40 and 41.
This is super cool.
This is crazy.
This
What
is
are we
super
doing?
cool. I never even would have thought to do this.
No, this is insane.
Never would have thought to put any of these other parts on those springs. Wires only.
I thought this is nuts. Okay.
That's the coolest thing.
Well, it's a good thing we didn't build this on a breadboard first. Like,
Okay, so step 2. Check the circuit for errors. When you are sure everything is installed correctly, push the power switch on. The speaker will emit a tone.
I have no idea.
Well, yeah, let's find out.
I mean, we got the fire extinguisher available. Yeah,
Yes.
it's under the sink. All right.
Excellent, excellent.
All right,
Okey-dokey.
ready? Nothing.
What about our DPDT?
You want me to
Swap
toggle
to
it?
neutral.
Neutral? No!
Sweet hit,
That's
dude.
crazy. What's the button for, though? We have nothing over here.
Okay, well, we're going to be testing circuits for it, so I guess that's what we need to make sure that the circuit works. Now we're going to be interrupting it with various other tests. The first test is our resistor test. We remove R1, the tone will stop. Replace R1 with a 100K resistor, the sound will now return as a buzz.
Okay, hold on. So if we remove our resistor, which we have right here.
Yep.
Oh wait, is it R1 was
remove R1. The tone will stop.
Which one was R1?
R1 is our brown, black, orange. Our 10K.
Our 10K one.
Our 10K went across springs 43 and 44.
Okay, so if I'm pulling this out, that's this resistor right here.
Yep, and we are going to, and it says the sound will stop.
It'll stop?
Yeah, I don't want to do it when it's on the...
Yeah, I'm not. I'm going to turn it on for initial. Okay, loud.
So we go ahead and we take that thing out and we put a 100K in there.
100K? I didn't even grab a 100K.
We have some left over from the last one.
Are those 100Ks?
Those are 100Rs.
Yeah, we have 1Ks. We had the 4.7s in the last ones.
Had?
Yeah, hold on. I got a 100K in here.
Okay.
I just seen it.
And that is our brown, black, and yellow.
Okay, brown, black, and yellow. Man, we really got to organize these things.
We get half of these.
Yeah, you take half, I'll take half. All right. 4.7, that's the one we had last time. 10R. You gotta look at them like Pokemon cards, man. I really, that's
100K.
kind of 100K. I lost. All right, let me get that.
Rockin'.
All right, I don't want to lose this. So what's the one that I just pulled out here?
You just pulled out a
10K.
10K.
10K. All right,
Brown, black, and orange.
dropping that back on the
I'm just
10K.
going to keep repeating those until we can kind of repeat them on our
Brown,
own.
black, orange. 10K.
Yeah.
Got it. Yep. Good call. All right, let me pop out the 100K. 100K. It looks like it is brown, black. It looks brown, black, orange.
Brown, black, and yellow. So if it's this one actually looks orange. Remember, our oranges looked, you know.
They look orange. That's crazy. All right, I'm replacing it.
100% look orange.
It looks so orange, dude.
43 and 44.
Yep, understood.
And it should return with a buzz.
A buzz. All right. Dude.
That's insane. Well, now it says remove C1, the buzz will stop. That's our capacitor test.
So remove it just completely?
Yep.
All right.
And so we remove it, and then we replace it with a
Nothing.
0.01 UF capacitor. The sound will again be a tone. The new tone will have a higher frequency than when you use the original values for R1 and C1.
0, 1,
103.
103. Are these the little guys that we have? These are 10s. These are all 10s.
Oh, it's going to be one of these little circles.
These
Okay.
little guys. Well, does it have a number on it?
103.
Oh, 103. Oh, fantastic.
I'll check these ones.
Let's see. There is
104,
nothing on these
104,
little
104.
guys. Oh, there is something written on them, but I cannot see what that is. Looks like 22.
That's a diode.
Oh man, I don't know if we're gonna be able to get that one. All right.
That's okay.
Yeah. That was between what?
That was
41?
40 and 41.
40 and 41.
All right. Well, I think that's actually a pretty good spot for us to
Stop. Yeah.
stop, because next time when we come in with this fully built machine, dude, that's the coolest
It's
thing.
so cool, dude.
Next time when we come in with our fully built machine here, we can go ahead and find our pieces. See if we can get a hold of some
Oh man.
over the next week.
Cool.
Absolutely.
Awesome. All right. Well, this was a lot of fun, man, and hopefully, I think we had some people watching. So hopefully you guys had fun too.
Yep, and I hope you guys are enjoying following us along with this book. It is an educational process, that is for certain.
So many wires. Slime ferrets like so many wires. Yeah, no kidding. That's an insane amount.
That is definitely a bunch of wires.
If anybody comes in here, we're going to try to leave this until next week so that we don't have to rebuild it again. But if anybody comes in here, they're going to be wondering what comes in the studio. They're going to wonder what type of bomb we're building or something. I don't know what's going on. That's scary looking. But cool. Awesome. All right. Thanks everybody for coming. Hopefully you guys enjoyed yourselves. We're going to continue with this every Monday. Usually around like 5-ish we'll start, and probably run for like an hour and a half or so and continue to work through this. Good news is this is just workbook 1. Hopefully by the end of this, anybody that joins us will be able to learn as we learn. And then if we're feeling up to it, maybe we'll continue the series in workbook 2. There's a way harder one where we get to build more stuff. I'm hoping that later on we could actually potentially start building it on the breadboard and using what we have. But then also maybe we'll start soldering them as we build them into little kits, which would be kind of cool.
That would be kind of cool.
Make our lives a little bit easier. What I'm hearing though is we got to go get more supplies for sure. So I might look through this book for all the supplies and bulk order them. Get a little thing in here so that we can
Excellent.
find
Yeah.
them a little easier. But cool. Awesome. Thanks everybody. We're going to call it a night. Have a good one and we'll catch you next week.